Hello, everyone. We are here for another Innovation Coffee episode. And today it's all going to be about simulation. So we've got someone from the Antmicro team. We'll tell you in a second who it is. And we're going to talk about Antmicro and Renode software for simulation. So that's going to be the focus of today. But before doing that, as usual, Robert, do you want to be... Oh, I've just got something that went off here. Robert, do you want to do a little recap of last week's episode?
Of course, yes. And thank you, Alessandro. Glad to be here once again. Welcome, everyone. So last week, it was a really fun episode. In fact, we got to meet Eben Upton. This was really cool because we didn't just kind of talk about or dive straight into, the whole tech stuff. We actually got to get to know him a little bit as well. So if you go watch last week's episode, I just copied it right here. I'm going to paste it right here. Last week's episode. Should have had that ready to copy paste. But last week's episode, again, with Eben Upton, we got to meet him. And then, of course, at about the 20-minute marker, we start to drill into the RP2040, the well-known chip that sits on the Pico among various other boards that are out there. So definitely go check that out. Not right now. Wait until after this episode. But definitely go check that out if you have an extra hour in your day. Back to you, Alessandro.
Awesome. So as we said, today it's all going to be about Antmicro and their simulation environment. So with us, we have Michael Gelda, VP of Business Development at Antmicro and also co-founder of Antmicro. So in a minute, he will tell us everything about himself and what he does. Hi, Michael.
Hello, Alessandro. Hey, everyone. Hello, Robert. Hello, everyone, and pleasure to be here. So what was the question anyway? Can you repeat?
Yeah, so we just want to give you some space to introduce yourself to our audience.
Sure. Basically, I'm coming from Antmicro, as Alessandro said, and a co-founder, of course, means there's a story behind us founding the company in the first place, and that story is actually tied to ARM, to be very honest. So basically, it was 11 years ago, going on 12, I think, when we realized that the future of computing would lie somewhere on the edge. We saw that there's a huge revolution going on in computers getting smaller and running Linux, right? We saw the smartphones rising. It was 2009, so already smartphones existed, but were still kind of not as popular as they are today and as omnipresent. Many of the different kinds of appliances that we have today, smartwatches being one of them, like Alessandro's wearing today, did not really yet come to exist in the at least popular, view. There might have been prototypes, but they weren't an object people would have considered buying, and so on and so on. We saw that people were hungry for smaller, lower power devices that could do machine learning on the edge. And basically, Antmicro was created from that notion where we saw open source software starting to dominate, Linux being more and more popular on smaller and smaller devices, the rise of the Android smartphone. All of these trends, seeing those trends, we decided, okay, it might be a good idea to found a company that's focusing around open source. It's helping people build systems that need those kind of edge AI capabilities. And of course, ARM was the default choice of architecture we'd go with for these kind of solutions.
Awesome. Thank you for that. That's interesting that ARM, you started with ARM and it made you kind of think of founding a company. I guess, you talked about edge AI. We'll dive into that perhaps slightly later, but I'm curious actually, back then, what was your kind of the push for creating a company? I mean, why did you feel there was a need for another company, right? And what was your vision back then? And I wonder if it's changed or if it stayed the same.
Very interesting question. So the vision for the company was related to the fact that we'd built quite a few systems. We were working at the university as well as collaborating with some external companies, building IoT systems. When it wasn't called IoT, nobody said IoT, but that was what we really thought. We thought the internet would go and reach all those corners of the world and connect all those devices. And we didn't call it IoT then, but we had this notion of connectivity everywhere and being able to access your devices remotely and over-the-air upgrades, all these things. 2009 and earlier, we'd been working on those concepts since perhaps 2004, where we saw, that these things were there. You could already start deploying them. We had some of the earliest implementations of like remote UIs on embedded devices spread around Europe that you could just log into via the internet and turn devices on and off and measure their parameters and so on. We had vast networks of devices that we operated. We had been building drones at the university. We had been building smart city networks, lots and lots of cool stuff. But then we looked around and saw, okay, but like the business world did not yet reach that level. We were actually kind of a bit ahead of the time with many of the solutions we were building. And we were kind of frustrated with only being able to do it in the research area, constantly just researching things, but never actually building the final product. We decided that we'd found a company that helped people build real stuff and final products, not just demos and prototypes. Of course, eventually we ended up building a lot of demos and prototypes as well, because we don't discriminate between this has to be a finished product. A lot of our projects are still very much R&D in nature, but very often we also get to take them to the next level and actually build them into real devices. And that's really rewarding. That's really interesting to do.
So, Michael, great answer. I love that. Two things I have really quick. One, I can't get over that background that you're sitting in front of. That is awesome. What a view. Where are you?
So I'm right now in Poznan on the 15th floor of our office building. We basically, of course, we don't have open offices yet. It's still the pandemic, but I took the liberty of walking into the empty office and just being able to host from here. We're hoping to be able to return into the offices as soon as the situation's under control. But yeah, it's basically the view of Poznan city center behind
nice.
me. This is our auditorium where we can kind of host parties when we will be able to host parties again, or show movies and do all the fun stuff that you can do in the office if you're allowed to enter it.
Nice. So that's really cool. Haven't been there yet. We'll be there one day. So I have my second question or comment here is, you mentioned how IoT wasn't a thing not too long ago, and I actually had a comment on that. I remember when I was talking with some folks from Qualcomm, and this must have been circa 2013, 2014. And correct me if I'm wrong, I feel that was kind of like that era when the IoT word was kind of starting to become a thing. Back then, Qualcomm tried coining the term Internet of Everything. So they were using IoE, and it didn't stick. It just didn't stick. It was nice. IoE was cool. Everything was Internet of Everything. But then I can't remember the exact day, obviously, but at some point, all of a sudden, it's no, it's the Internet of Things now. And everyone just started calling it IoT, Internet of Things. But anyways, silly anecdote.
Yes, I can remember the same period of time when it was still you had machine-to-machine communication, right? That was a term at one point. Nobody remembers that word anymore. And so on and so on. There were so many of those kind of terms being coined. IoT stuck, but interesting enough, and I think that'll be a segue into Renode, is IoT rolled out a little bit differently than people had thought. And it's obvious, you always underestimate what can be done in 10 years, but overestimate what can be done in 5, right? That's as the saying goes. And we're humans. We're kind of obviously making those mistakes over and over again. I might be making some of those mistakes talking to you today about some of the future trends and so on. I'll probably get 70% of those wrong. But it's kind of interesting when you look back, right? And you remember those moments when, hey, that didn't used to be a thing. Now it's so obvious that nobody even talks about it.
Cool.
Everyone's nodding their heads
yeah. I'm waiting for
the good times.
No. We just try not to step on each other because it's, given that we're all virtual, we can't see each other speaking. So, but no, I mean, that's really interesting. And I think it's the truth, right? We're not good at making predictions effectively, right? And most people just get it wrong. And I think that's part of life, right? You just have to live with the fact that, predictions are usually just that, right? You're not able to see the future. So, but I think Yeah, that's interesting. Right. The next bit was we have, we told you earlier, we've got this these segments that we do, right? And today we wanted to play around with one of the segments we have called Innovation Cribs. So we really, even though you're not really in your house, because we've been doing this when people are at home, but we would love to see what you've got lying around. I mean, we know that you've got a lot of hardware that you work on, so. Yeah, like show us your desk or your auditorium in this case.
Well, actually, it's hard for me to show the desk, but I can show you the boards that are lying like on the desk. And I specifically took boards that were lying around because obviously that's the fun part. Like, what are we actually working on? I can't show you some of the customer projects. I can't show you like custom hardware designs belonging to our customers. Increasingly, of course, we do more and more like open hardware, right? We actually design boards and put them up on the internet. I might show you one or two of those boards later, but many of the designs we do, of course, are like proprietary for someone. So we try to put as much open software on it as we can, and typically we even succeed to do that. So I'll show you dev boards, obviously, but the dev boards might suggest, the kind of things we do and what's kind of on our minds recently. So one of the boards that kind of got me a little bit interested is this Rockchip 3399 solution. We've been building a solution for smart exercise for a customer running Android, right, on this one. It's, of course, a system on module. We've been building a lot of solutions built on system modules. You'll be able to see on our GitHub that we actually publish a lot of baseboards for different kinds of boards. So that's one I actually had lying on my desk because I was pretty amazed with like how cheap the hardware gets. And this has got PCI Express. It's got quite a lot of firepower, all the interfaces you might wish for, and you can buy a SOM for $60. So that's kind of one of the things I've had lying around. And you can imagine us working on quite a lot of these kind of solutions for customers, like smart exercise equipment, which of course, like in the age of COVID, as you might imagine, people want to do quite a lot of that kind of stuff. Another thing that I have lying around on my desk is Google Coral. Actually, yes, that's RK3399. That's correct. Now, this is Google Coral. We actually work with Google quite a lot. They're a customer and partner. The Coral team are quite awesome. They've been building, lots and lots of solutions where you can just embed AI into stuff. And this particular thing is a SBC built on a SOM. The SOM has an IMX8 on it, an NXP IMX8 quad-core CPU. And of course, you can do both like run Linux or Android, and then also accelerate AI stuff in this solution. So kind of one of the other things we're working with. And we also have an open source baseboard for Google Coral. Another thing that I have lying around is, a Raspberry Pi 4, right? And the Raspberry Pi, of course, everybody knows what it is. The reason why, we have Raspberry Pi 4 lying around is that now that it's really a quad-core, 8 gigabytes of RAM and virtualization capable solution, it's really capable of running in a server room even, which is actually what we're doing, right? So one of the projects we're working on is like building an army of ARM-based servers based on COTS hardware, including the Raspberry Pi 4 compute module. I couldn't find a compute module on my desk, unfortunately, but like a lot of my colleagues have those. I assume it wasn't there because like people just took them home to work on this project. But I might be able to show you later, this server board that we'll be working on for the compute module 4. So kind of that's, and there's of course plenty more. There's some NVIDIA Jetson hardware I had lying around that I just couldn't carry as much as I wanted. We do a lot of stuff with NVIDIA solutions, building edge AI applications. So we have actually a very successful baseboard for the Jetson Nano, Jetson TX2NX, and Xavier NX. That we just put out on GitHub, and you can just go and build stuff and get our help to customize it for your needs. So that's in the kind of a little bit higher end stuff. And today, I think we'll be focusing more on microcontroller world. And of course, in terms of microcontrollers, I also have a lot of them lying around. Some of them not so small, like this ST board. We have a nice collaboration going on with ST Microelectronics. We've been simulating a lot of their boards in Renode. We've been building a lot of solutions with ST. We have a lot of customers using ST microcontrollers, so obviously it's very easy to. We're even in some projects together. So in that sense, ST is quite omnipresent on this market, and they have a lot of things, big and small. This is, I think, a L745 CPU. Other boards that I have lying around is, this Zoletia Firefly. This is a dual radio solution, like 2.4 gigahertz and 868 megahertz solution. We can simulate that in Renode and bridge, different kinds of networks together. So I think that's a pretty interesting board because, typically you put those two radios on two different boards. This is integrating that into one. I have, a Silicon Labs board, and that's funny because we actually know this board and those guys from their Energy Micro times, right? We've been talking to them. Like, you can see that we've already been on the market for quite a while because we've seen the entire evolution of that company, and we've been talking to them on various stages of their development. And of course, we know Scilabs of today, and we can also simulate this in Renode. And the main star of what I have on my desk and what I will be probably presenting the most about today is this little guy. You can barely see it, right? The Arduino Nano BLE 33 Sense, we couldn't come up with a longer name board, right? I mean, the name is funny, but the board is actually pretty awesome. You can basically do quite a lot of sensor-related stuff on it. It's a Nordic chip. Nordic does a lot of awesome work in Bluetooth world. They're very open about their solutions. They have open networking stacks, and they work with Zephyr quite a lot. So they're also kind of good friends of ours and collaborators. So quite a lot of hardware on my desk, and that's not even all of it.
Awesome. So you showed us all these boards, and you said you had all this on your desk, right? But actually, we invited you here to talk about simulation. So I'm curious, how do you go from, why all these dev boards? Actually, sorry, let me rephrase the question. People usually work on dev boards, right? But we're seeing this trend with more and more people wanting to simulate stuff, and how did that start? How did that start, and why did it start? And what is your take on that trend? Do you see that as well? And is that something that you think is gaining momentum?
Well, absolutely. There's, I think it's both the maturity of the market itself that's kind of pushing this. And I can tell you a story from the very beginning when we started in, 2009, and Renode was created in 2010. Right, so we'd actually created it right at the beginning of the company. We saw that working with physical stuff is hard, and hardware is hard, as they say. Hardware is hard, and so how do you make hardware less hard, right? You don't want to throw hardware out of the window and become a cloud developer. I mean, some people want to, but people that like hardware, they want to think about how do I make my life easier? And we just thought about making our life easier by designing a simulator that would be very flexible and allow us to build things without having to rely on hardware all the time, and doing 80% of the development flow in simulation rather than on real hardware. And then, of course, at the very end, you still need hardware, or alongside simulation, you still need a lot of hardware. But simulation gives you this ability to go anywhere, work from anywhere, and collaborate in teams between different people, between companies. That real hardware it's kind of hard to do because as long as you have a dev kit, that's okay. But as soon as you go to custom hardware or you connect two boards together and so on, it becomes so difficult to replicate physical setups, right? So we decided, okay, we need a simulator. And we created the simulator for ourselves, right? So Renode was created for our internal needs. And we had this notion we might open source it at some point and so on, but this grew on us and grew. And since we were working with open source so much, right, we've been using Linux everywhere, and open source real-time operating systems and open source libraries. Everything that we tried to build was based on open source software. We thought, okay, it's it doesn't make sense as a closed tool. It only makes sense if it's an open framework, accessible to everyone. Everyone can innovate with us. It's also just a good marketing strategy. So somewhere in 2015, actually, we went and just open sourced all of it. We thought, okay, what should we open source? Open core? Should we do no? We just said, okay, you know what? For the sake of this workflow and the tool itself, let's just give people everything, and this will enable everyone to do the stuff that we do as effectively as we do it. It still means that most people come to us when they want something related to Renode. So we think open sourcing Renode was the single best decision that we could have made. Possibly we should have made it earlier, but
So, Michael, real quick on that note, I'm a huge open source fanatic here. I love anything open source, and when companies choose to open source their stuff, I think it's just great. I'm kind of curious. What are some of the, if you could list out some of the benefits of going open source? Pushing your product up there, and also, have you seen substantial contributions? Have people found any bugs and reported them? What are some of the benefits that you've seen from going open source? Because you did say it was one of the best decisions you've made. Now I'm curious, could you give us that 3 biggest bullet point list that kind of list out those benefits?
Absolutely. So yeah, I mentioned that it's both a maturity of the market thing, and there's many factors at play. And as the market grew, we saw that the way to capture the growth is to be out there in front of people. Even though we're getting more and more known, but we're not the kind of brand that everyone kind of says, oh yeah, Antmicro, I know who it is, right? But if you do open source, if you build your things out in the open, people will eventually find you, and word of mouth will kind of circle around. And people can just go and try out the stuff you're doing and see if it's good. And if you like it, they're going to talk to you, right? And imagine we were just closed, we sold the tool. What would happen? People would just run into, oh, there's a simulation framework. Okay, I need to pay someone or get a license or something. I don't do that. Personally, I'm a developer too, right? I'm not just, yes, today I mostly manage people and relations, but I actually am an engineer. So when I try things out, I never subscribe for a trial, right? Let's face it. I download stuff from GitHub. I just try it out myself, even to this day. So that's one thing. Basically, the good thing about Renode, you asked about contributions, for example. So let me paint a picture of who's using Renode today. We have Google using, contributing, paying for development, doing custom projects with us in multiple groups, right? We have, we've had people like Intel. We have Microchip that is sponsoring platforms in Renode. We have QuickLogic. We have Microsoft recently has been contributing quite a lot around performance and visualizing UIs on microcontrollers. We've got the biggest names in the industry either working with us directly or perhaps contributing into the framework. And I don't believe this would have happened just on its own. Even the tool might have been just as good as it is today. And I believe we couldn't probably have been as good without being open source. But let's assume that we could have, right? Let's assume we could have been building this out in secret, and the tool would have been just as good without the input we've been getting, without all those interactions and free electron kind of bouncing into each other. In that world, I think that we just wouldn't have those big names working with us, because it would just get stuck on some level, right? Someone has to give a green light to actually work with you. And then if it's open source, there's going to be engineers in a company that are gonna take your tool, start using it, start looking at this stuff, start reading tutorials, playing around, realizing it's great, and then they'll find a way to work with you. That's what we've been seeing. That's kind of the biggest advantage, I think.
Yeah, people who have watched me on these streams, I've told this story multiple times, but basically I've always looked at open source as kind of like the win-win-win model, where you mentioned it. You said we created this simulation tool because we needed it, right? I mean, either way, no matter which way you cut that, you won because you made something that you needed, right? Then you open source it, and if someone else needs it, they can go consume it. They win, right? And then if they find something that they want to make better, more robust, and or report a bug, contribute in any way, they contribute back to it, and then Renode wins again because now you got contributions back to it. And so this whole win-win-win cycle that people experience in the open source space, I think it's just amazing. And you've pretty much touched on it, so really cool. And yeah, Alessandro popped this little thing up here on the bottom, but just a reminder, if anyone has questions for Michael or Alessandro or I, please feel free to post those. I want to dive into this one question here because this is on my list of questions. So when you go to the Renode site and you see Renode by Antmicro, we haven't really talked about Antmicro yet. So could we just get a quick kind of synopsis? What is Antmicro? How is Renode part of Antmicro before we kind of dive into, it looks like a little bit more technical questions here after that?
Okay. So what I was saying before is actually mostly about Antmicro, my company. It's been around since 2009, and the Linux on ARM thinking and open source for everything. That's actually Antmicro's way of thinking. Renode's just part of the company. It's one of the teams that we have. It's one of the projects that we run, one of the bigger ones, and it shares that kind of way of thinking. It just so happens that it's also caring about one very specific product, you could say, right? But the company itself does a lot of things. We do quite a lot of work around open source FPGA development, open source hardware boards. Like I just told you, we're building solutions for edge AI. We're building AI stuff. All of this is Antmicro. It occasionally, of course, we use Renode ourselves, so obviously those things kind of intermingle quite a lot. But then again, of course, the outreach of Antmicro is kind of quite broad as compared to just Renode, right? We love when we can combine some of our other interests with Renode. So when we're working with some interesting space, building some kind of a sensor system, and it turns out, okay, Renode could be used there for simulation purposes. That's awesome. But a lot of the work we do is, we build things that the thing that they share with Renode is the open source way of thinking rather than actual, use in that specific project. Yeah, so I hope that answers the question a little bit. So my company
Awesome.
Antmicro is it's around 80 people now, right? So it's kind of, you can imagine more or less the size of the company itself. Of course, open source is giving us a lot of firepower to collaborate with other people and build things in a much broader ecosystem than we would have normally if we just had 80 people building proprietary stuff. So we're running a huge number of projects concurrently.
Nice.
Cool. Awesome. So we talked about, we saw some of the boards that you've got lying around, and we talked about the fact that you simulate most of these boards, and we talked about in general, what Antmicro does aside from Renode just now. I'm curious actually to see Renode. Let's meet him, right? let's meet the tool. So I know you've got a couple of demos for us, or a couple of things that you wanted to show. So let's start with that. Then we've got a bunch of other questions, but I'd say let's go into that. Let's dive into that, and then we can maybe ask you questions during or right after, and answer any question from the audience as well.
Okay, let me try. I have a few demos, and let me perhaps reverse the order I was kind of going to show, and just start with something that might kind of give people a feeling for what it could do. Just let me move this window around so that I don't confuse people too much. Okay.
I'm getting my snacks ready so I can watch,
Go ahead. Share screen, and let's share the screen with Renode.
There we go.
So I'll start with what I wanted to show last. Can you see this now?
Yes.
Perfect. So I wanted to show this last, but I think it's actually kind of cool to start with this. This is what we've been building for Google, actually, and in collaboration with Harvard and basically the tiny machine learning crowd. So actually, this is built around this little board here I was talking about, the Arduino Nano Sense board. This is a collab, so an environment in the cloud where you can run Renode, the simulation of a board, this board, online. And basically, I wrote a small shim. Yeah, I'm an engineer, right? So I wrote this small shim allowing you to talk to Renode from Python because I thought that would be cool. And so we, by the way, Renode itself also has a Python engine inside it. If you're really into Python, you can do quite a lot of stuff with it. But I wrote a script or a library to talk with it from the outside so that we could embed it on different kinds of websites. And my team has been putting an incredible amount of work just showing people what can be done. For example, if you put Renode in cloud, if you run stuff. So basically what this little Jupyter notebook, it's essentially a Jupyter notebook, right, does Google calls this Colab because it's connected to their compute platform. You get servers for free. I have this server running here with some memory and disk space. And so this is actually, I've already kind of pre-run this, right? And what it does is it downloads Renode, installs it into a virtual environment, and just goes to execute some code which will run person detection on this photo. This is the default photo we use. I can take a snapshot of myself. I won't try that now because I'm using the camera for the stream. But there's an option here, basically a default, take a picture from camera or upload your own, right? I should have taken one and uploaded it. But
I've tried. I can certify that I've tried this and it works.
Yes, because it is a cloud demo. It is a cloud demo. Yeah. It's there. It's open source, right? Like you can see the links up here. So these are real links that just take you to the code. And Colab just gives you servers for free. So if you want to replay this, you'll be able to. And so Renode runs this, and Renode actually takes this. This is done with the Google TensorFlow Lite team, right? So Google takes this image through TensorFlow Lite running on this virtual board, right? And then it just spits out the result of the processing, just like you would have on the real board. And Renode, of course, also gives you an ability to, since the board is virtual, the board is in your simulation, you can take whatever data you want from the simulation and, for example, plot it, right? So here we have a plot that just displays the amount of executed instructions. Obviously, it was pretty linear because we just run some kind of processing algorithm or exceptions that were being called. There's of course more plots you could do. These are 2 example ones. But in general, you can imagine all these kind of data you can get from this virtual device. You can actually take this data and track it throughout the progress of your development flow, right? So it's not just like an interactive thing. Here, it's an interactive tutorial to walk you through TinyML in the cloud. But in essence, that can also be integrated. And with many customers today, we're working to integrate these kind of functionalities into their CI systems, right? Because as I was saying, the world is finally ready for IoT. It didn't used to be. Many years ago when we created Renode, we had the ability to simulate many nodes, but people didn't really do many nodes yet in that kind of scope that we thought they would. But today they are, right? Today people are trying to build huge complex systems, and we can basically simulate those systems, take the data from those systems, analyze what's going on, and debug it very thoroughly. So I think that kind of shows you a little bit how you can integrate Renode with other stuff. I see we have a couple of questions, so I'll shift over to you.
Yeah, I was going to say a couple of questions from the audience. So we got Sandeep asking, does Renode also support simulating sensors connected to the board?
Yes. So that's a great question. And actually, you can see already in this code, here we're just calling a bunch of Renode commands from my library. And basically, the spy to camera will suggest to you that, yes, absolutely, we simulate all kinds of interfaces in Renode, communication interfaces, and then we connect virtual sensors into those interfaces. You can input data, just like we input this picture here. For this Arduino Nano board, we actually have simulated most of the sensors on this board and various connectors to that board. I think it has also this camera board, right? So basically, what we're simulating in this Google Colab is this camera board. And let me just move over quickly to the second demo to illustrate this, because I think that's an excellent segue.
Michael, before doing that, perhaps we can just 1 second, because we got the second question that's related to this demo. So Carlo is asking, you're using precompiled binaries on this example. Would it be possible to edit the Arduino code on the fly as well in a Jupyter environment? Have you done that? Have you tried that?
Absolutely, yes. We have notebooks that run from source. It just takes a longer time to run them. So that's the only reason. But yes, we have been running Arduino CLI in the cloud. Obviously running Arduino IDE, putting it in the cloud kind of gets difficult just for the UI reasons. But absolutely, yes. And also Renode, I'll turn it on now. And Renode comes with a lot of demos. And many people ask us, oh yeah, but these are pre-built binaries. Well, that's the only way we can show people stuff, right? We have to have pre-built binaries, because otherwise you'd be like, here's a platform, it does nothing. Like, nothing pops up on the screen. That's so cool. I don't think that would have worked so well. So we have a lot of pre-built binaries that we ship, or we don't ship them. We just download them from the internet, right? We host them on our website. But of course, you can run your own code. That's the whole point. So like at any time when I'm showing something and there's a binary being loaded, just you can substitute that binary into any binary you compile. And that's the important thing as well. You take a binary for specific hardware, you don't have to change it. It's like for the Nordic board, just take a binary as you would normally and just put it in Renode, it'll work. Assuming, of course, you've modeled the right peripherals and so on, it'll work like in the hardware. We don't want people to be modifying their software to run in simulation. We want them to run software as is in simulation. And that's what I'll do right now. If there's no like other questions that need answering right now, I think showing this bit would really help.
All you. Go ahead, please. Thank you.
Great. So you can see a bunch of windows with a Renode logo. That's our own terminal emulator, by the way, and we can do images, so that's why we have an image. And it's Renode version 1.12. We've just released it this week. Yay. So there's a lot of cool stuff there. So I have this monitor. It's like this CLI, and you can of course script this. You don't need to do this interactively. You can do this from CI, but like for demo purposes, I'll be showing the CLI. We have a lot of demos, as I said. Like if you do the I command is just short for include. So let's include the script for like a single node device. There's quite a lot of those there, and let's just go with like an NRF, right? That's a Nordic SOC, the one that's being used in this board, right? And here a window popped up. This is a UART window. This is going to show us the characters that get printed on UART. And right now the simulation is not started yet. So of course, thank you for the link here. Let us start the simulation, right? And this is a Zephyr binary, and this is a console demo. So we have a console. Yay. Okay, like I could do the same on the board. Like, what's the fun in this? So basically, fortunately, we have quite a lot of stuff to show here. Let me just kind of go to my script and see, what I need to do. First up, basically, we can take and show you a list of peripherals that we have in a simulation, right? So here is our virtual board with stuff connected to the system bus, and you can see the Cortex-M CPU, you can see some clocks, you can see GPIOs, lots and lots of stuff. I don't know if the size of the font is good enough for you. I don't know how to increase it, but generally speaking, we've modeled all those peripherals. You can see them on the system bus. Now, we have a nice logging capabilities. So we can change the log levels on different things. And for example, the NVIC, which is the interrupt controller, let's silence this so that we don't get a lot of logs. And by the way, the log window, this is here, right? So here you can see the log window, and you can see why I'm trying to silence the NVIC is just giving us a lot of data that we don't want to see. And then we can basically do quite a lot of fun stuff, like, for example, logging different stuff related to our UART. Let's log the peripheral access to the UART. So like whenever this peripheral, whatever the UART is being accessed, we're going to get messages in the log window. Okay, we've set that. And I'm typing here. You can see, okay, we're having those accesses into the UART. So something's trying to read and write, UART data. That's great, but like, what's going on here? Let's see some more info. Let's go and try to log function names for. We have tab completion, so even if I forget the commands, and if I could get those kind of interactive help commands. And let's just log functions that are related to UART. So these are the names of the functions in Zephyr, in the driver, that would be doing something with the UART. And now, every time I type in the UART, I'm going to see, okay, we're actually entering this function, and in this function, inside the function, something's going on, right? So we can now corroborate this info. We can now see that whatever's happening to my binary, imagine that you didn't have the UART output, right? Like very often early in the flow, you just have nothing on the UART. It's like, what's going on? In Renode, you're actually going to get information, which functions are being called, what registers are being read. You can debug very effectively. Of course, you can also debug with like GDB and so on. That is totally fine, and it works very well with Renode. But on top of that, you also can get extra information. Essentially, you can get a full trace of all functions. We can actually now go and enable, logging function names on all functions. And then when I type, I'm gonna get a lot of functions, right? Because there's quite a lot of functions happening. Zephyr has, a nice several levels of abstraction. That, of course, if you try to log all the accesses to everything that's happening, it's clearly quite a lot of stuff going on. So basically, I think it's good to. I hope this made you realize like what Renode does on the basic level, in the basic sense. It simulates boards in this binary compatible way, gives you a lot of data that you can analyze, gives you a lot of debug capabilities. That's like the basic functionalities of Renode. Any questions at that point? Should I?
Awesome. We've got one question actually. I think actually I'm going to expand on it a little bit. We haven't touched on how you actually simulate the CPUs, right? So I'm actually curious. You're simulating ARM CPUs here. What is your approach, and how did you manage to do that? And then we can take this.
Absolutely. This is dynamic binary translation, right? This is like much like the approach that QM uses. It's basically translating instructions from architecture to architecture, with of course some clever mechanisms around caching and so on. So that's kind of like on a very basic level what the core simulation is. In terms of what the entire framework does, we model different kinds of peripherals and I/O, bits, right? Like plug and play boxes, you could call them, like the GPIO controller here, or an SPI controller there, or a UART, or a PCI Express controller for that matter. We model those in our framework, and we build platforms out of those. Those platforms look like this. Actually, this is very similar to what the format for defining platforms in Renode looks like. It's called REPL. And so, yeah, I could, of course, go into much more detail, but I don't know what you want to hear.
So I guess to answer, I think it'd be interesting to kind of get this question now. Do you update Renode CPU models as new chip errata is issued? So I think that's why I asked you the base question of, how do you model the CPUs, and do you do updates to them? I guess that's to answer Adalbert.
Yeah, I mean, essentially, if you want to model errata, you'll have to do that. If you don't want, much of the work we do is not only focused on existing chips, but also like upcoming stuff. And then, of course, it's an interesting question, actually, where sometimes you're in this situation where you actually have support for something and it's not out there yet on the market. And you don't know if should it be supporting this device just as it is, or perhaps as it's gonna be, or which version of the silicon exactly? These are all tough questions. Yeah, but the answer is, of course, if the operation of a certain piece of silicon deviates from what it was supposed to be, eventually, if you want to simulate the board properly, you'll have to model the part that is working wrong, right? Fortunately, of course, a lot of people ask about silicon errata, but let's face it, this is not really happening that often, right? Most of the time, what you're hunting for is not a bug in the CPU, right? It's most of the bugs that you really make is your own software. Let's face it, it's bugs that you just made because you were tired, and things that just come up because different teams are working together and they just didn't realize they had different ways of doing things. So most of the bugs we hunt for, most of the capabilities of Renode face this kind of software development flow where you just run into those issues that in the higher level software world, on just running stuff on x86, building, your cloud software, you have vast debugging capabilities, right? You have lots and lots of options because you're just running on the same machine. Everything's easy. You have lots of tools. But if you're running on hardware, you suddenly your developer machine is one, and then the hardware is another. And getting all the data that you need out of the silicon is just hard, and especially replicating development experiences, replicating development setups is just hard, and that's where simulation helps. So don't think too much about like silicon errata. Think more about, oh my God, I made this typo and it's going to take me like 2 days to fix it. We want that to be 1 minute, right? And hopefully, that can be achieved with Renode.
Awesome. No, thank you for that. And it is a different approach, right? Because you're not, you're trying to simulate the board. You know, it's not really about the silicon. It's more about the board, and you're trying to enable developers to iterate quickly, right? That's the goal.
Absolutely.
So that makes total sense.
So real quick, if I may, I think the simulation aspect is awesome. Simulating hardware, it's really cool. We've been simulating all sorts of things for a long time now, right? You can simulate circuits, you can simulate IC design, you can simulate building bridges, like all these kind of things. So simulating hardware, why not? My question is, I guess, and I kind of think I know the answer to this, but why would someone choose to simulate a Raspberry Pi instead of going to something like mini nodes and checking out a physical piece of hardware to work on, like through one of these, mini cloud companies? I guess it's similar, you could say like, oh, well, why don't I just plug one in on my desk? But that's kind of like besides the point, because you don't want to have to plug all this stuff in. So I could go rent or lease a hardware piece from mini nodes or Mythic Beasts, or I could simulate this with Renode.
And by the way, it's not an either or. That's the whole point that we're trying to get across, right? Like, and many people ask us, oh, but I love my dev kits. Like, will Renode eradicate my dev kits? No, it'll make them more fun, right? Like, and also like renting hardware. Do you remember this? I was talking about Raspberry Pi, right? So let me show you. Let me try to open this image here and show you what we're building right now. Like and this is one of the many things we're doing, right? So it's not to show you that like this is the pinnacle of achievement, but more like it's exactly to the point here. We're building this ARM cluster, right, of boards ourselves, right? So like to your point. Of course, you need stuff like rent your own Raspberry Pi server and stuff like that. It's not that we want to. Actually, most of the activity we get these days in the ARM world is around microcontrollers, because like, where's the services allowing you to like rent 1,000 STMs? Like, you could build something like this. It's not impossible. We've seen people do this, but like, does it scale well enough for like hundreds of thousands of people to be working on this hardware? I would say no, right? So to your point, we're building this server solution on the Raspberry Pi 4 compute module here, right? And this is going to be like something you put in your rack, and you can kind of run plenty of those and have a scalable, like flexible firepower, compute power for your needs, like both our own and our customers' needs in the data center. And we absolutely need that, right? Like we're not going to like simulate that. It doesn't make any sense, right? And even if you want to just test, for the high-end devices, you might indeed want to go and rent something in the cloud. But for most people, especially when they're running like systems of dozens of nodes, for example, you're definitely not going to go and try to like rent those devices in the cloud. With Renode, you can actually just like simulate them with a program, right? And this program is an open source program you just download, and that's it. You can put it in your data center and run it for free. And we help people to do that. We help people like model new devices, integrate that into their CI flows. But it's not an either or. Like, I'm not like, I don't want to attack, other things saying, oh, it doesn't make sense as a service. No, I think all of those things will have a place, and you'll have an array of solutions at your disposal when you're building different kinds of systems. And potentially you could even like rent a server in the cloud and connect that into Renode, because in Renode you can co-simulate things. You can, plug in virtual boards into physical boards, like bridge Ethernet, and so on and so on. We've done that, and we do that. We've had a lot of discussions and work with, AWS and others, like bridging, real nodes with the cloud, right? And then obviously, it has this physical world element in it. You can't go around this. We're not saying simulation just takes away the need for the physical world to exist. I view it as like different aspects of trying to solve the same problem. really.
Would you say that there are different stages of projects, let's say, and in some stages you use more simulation, or it makes more sense to use simulation. In other stages, it makes more sense to use real hardware, or do you see it more as a continuum, and things depends on people's choice and I guess what hardware you're looking at?
Absolutely great question. So a lot of people approach us and think that simulation is all about, like, I don't have silicon yet, so I'm going to simulate. And we tell them, look, yes, if you don't have silicon, obviously you cannot simulate. But if you already have stuff, you have to test it, right? You have to repeatedly, and you have to deterministically, for example, test it. You have to, and one of the little, I think that one's going to be very fast. So let me just try to show that. One of the very fast demos here is testing with Renode, right? How do you test things? And it's really simple. Basically, let me just quit this simulation I had running here. Let me just close that little board here and minimize this. So we have this Renode test script that just runs Renode, like for example, CI purposes. This is integrated with the robot framework, which is a test framework for just writing natural language tests. And the Renode tests here, we can go and where was the platforms? Yeah, I think it's here. So essentially, you know what? No, I'll actually run a failing test. I have a failing test here that I prepared. I just forgot about it. And this is just going to run Renode and run a bunch of tests. I can show you the file later. And in a few seconds, we're going to see that the tests failed because I made them fail. I've deliberately edited the test to fail because it's so much more fun to see a test failing. And if I open it in Firefox now, I think it's called report HTML, right? You can see this failed test here. You can open it, and it should run Zephyr tests, and it's looking for like project execution successful. It's looking for project execution not successful, but like the execution was successful. So the strings don't match, and it's saying, this keyword failed, right? So all of these things went well. The emulation reset, and like the machine was created, and everything started, but it was waiting for a line on UART, and that line never appeared because a different line appeared instead. And this is like how you can test Renode repeatedly, deterministically. You can put this in the CI, and like putting real boards in CI is just a pain. It can be done. People have done it. We have done it. But for like, imagine infinite scalability also for small teams, or perhaps many teams across a large organization like Google. We've actually put Renode in many of Google's internal systems because like people won't bother with like buying a dev kit each, right? Like that's not going to happen. Whereas if you tell them, hey, there's a program you can run, and like it's going to just do its stuff and you're going to get a result, they're software engineers. They're going to do it, right? So yeah, hopefully that answers the question.
Also, that's perfect. We've got only a few minutes left. Last question I have for you is around where do you see this going, right? Like, I think you mentioned a couple of things that are interesting that perhaps could be interesting to explore. And I don't know if you are already, like you mentioned, for example, multiple nodes, right? Like, and I wonder if you're already doing this, or if you're thinking of doing it, simulating fleets and interaction between different nodes. And it's an open question really to you. Where do you see the simulation world evolving into, and how much is it going to change in the future?
It's a great question again, and like referring back to the previous question, which I didn't answer in full. So how do I see people like working with simulation throughout the development cycle? I think they should be working with it throughout the entire development cycle. Of course, as the development cycle matures, let's say, you're going to use more and more physical hardware because you're going to deploy it. But if you're deploying real hardware, you're probably running lots of custom configurations of that hardware. Perhaps those configurations have to coexist. Perhaps versions of your firmware have to be changed, and so on. So all of this stuff can be tested in Renode, like what happens after my firmware upgrade, or how the different versions of my firmware coexist. So the more you do, you should actually be using more and more Renode. And of course, more and more physical hardware, that there's no way around it, and we don't want a way around it. So I see personally, and perhaps referring back to the maturity of the market argument, we've developed Renode to do multi-node somewhere around actually before it was released open source, so before 2015. And then nothing happened for a while. Like we had traction, we had some customers, but like people didn't do multi-node development, right? And the reason was people really didn't do multi-node development too much. They did some. They, of course, products were built. I'm not saying that nobody was doing sensor networks, but like much of that stayed in the R&D department. It was, like just like universities trying to build those, like people deploying real smart mesh networks of devices. This is really happening on a grand scale now. And we're seeing more and more demand, and our customers, the customers we are getting now, they're coming and specifically asking for multi-node setups, right? Before, a lot of customers asked about, can we just simulate this one node? We want to prototype that kind of hardware. But right now, almost every case that comes our way is we want to connect X to Y. How do we make that work? And some of the most exciting cases we're working with now, like big names in like power electronics or like in energy and IoT, big names in like white goods, companies are coming to us and saying, we now need to simulate connected devices because devices are now connected, and that's like totally screwing up our development cycle because nobody thought of that before. We used to be focused on one node. Now we have to do like node to a phone or like node to another node. Like we don't have a way to develop these kind of things. Can you help us with Renode?
Cool. No, thank you so much. I think that's a great glimpse into the future. And Michael, we have to close this out, conscious of your time, conscious of the time of our viewers. Last comment here, it looks like John Moore says, Renode sounds like a very valuable tool for testing edge AI ML devices. And I'm sure you could think of many, many other use cases, but it has just been a true pleasure speaking with you. Thank you so much for joining us. Thank you to all of our viewers. This is your chance. Last 30-second shameless plug. Do you have anything you'd like to tell the audience to go do?
Go download Renode and play around. I mean, that's anything I have to say. Like, go and download Renode 1.12. Enjoy it on Linux, Mac, and Windows. Try to do the Colab stuff. This is the links were there, I think, or we'll probably paste the links with. Yeah, there's Arduino integration, so you can try it out from Arduino ID as well. That's pretty recent. Also, kind of a part of our Google project. So just go ahead and explore. There is a presentation. I'll actually, after the show, I'll share a presentation with you guys that just summarizes lots and lots of things about Renode, and that'll point you to a lot of tutorials. And if you're just not sure if you can do something with Renode or you want to do something with Renode but don't know how, just reach out to us. We offer commercial services to help in using Renode and implement new platforms and so on. That's what we're here for. That's our entire business, more or less. So we'd be very happy to talk to you. Don't be shy. But if you are shy, just go and play around with Renode, and you can talk to us later.
Excellent plug. Alessandro, did you want to ask one last thing? I think you maybe had a question or no?
Well, I mean, I think, interesting. I'd be interested to know, as everybody probably knows, we've launched ARM v9, right? So I'm interested, actually. I haven't asked you this earlier. Are you already simulating ARM v9? Are you doing anything around that?
Unfortunately, no, but we'd be very happy to work with ARM to enable that. So that's my question, I guess. My answer.
Awesome.
Cool. Well, thank you. I mean, Michael, it's been a pleasure. Thank you so much for taking the time and to walk us through all the different demos that you had. It's really cool to see this open source world of collaborations and great stuff happening, especially around, I'm a big fan of the TinyML space, and there's a lot of stuff happening there that you guys are enabling, and it's really cool to see. And it's good to see the usability of the, I've played around with the Arduino examples. I'm going to repost them here for everyone. But it's super easy to get that running, and you can actually, as you were showing earlier, you could see pictures coming from the camera, and it's you can actually interact with the simulation really easily as well. It's the user experience is great. So
and we're just starting, right? So we're developing in that direction more and more. So just stay tuned for more of this. Thanks a lot, guys. It's been a pleasure.
Awesome.
Sorry, I was just waving at someone that said bye in the chat, but awesome. Real quick, Alessandro, if I may, I need to do one shameless plug for one of our community members here. So iShot JR is going to be hosting a an Atmega Zero workshop. I believe it's free, but feel free to go to that link, check it out. Let me just click this right here so we can bring it up. iShot JR, one of our leading community members, he hosts a bunch of meetups through the All Hands Active. Make sure you go check that out if you're interested in learning about the Atmega Zero. And pretty cool. So once again, thank you so much, everyone, for your time. Cheers. There you go. Innovation in coffee. It used to be pizza.
It's tea for me, but yeah.
Tea. There you go.